Good morning, everyone, and welcome to the fiscal year 2023-2024 Standard Plans Update. This morning, your presenters will be Standard Plans Publication Engineer Rick Jenkins, Standard Plans Engineer Richard Stepp, and Structure Standard Plans Engineer Joshua Turley. Please submit any questions to the question dialog box. We may attempt to answer questions as we go, at the end, or even after the session. And with that, I'm going to turn it right on over to my friend, Rick Jenkins.
Well, thanks, Brian, and good morning, everyone. My name is Rick Jenkins, and I am the Standard Plans Publication Engineer in the Roadway Design Office. This is our annual Standard Plans Update training. Today, we will go over the changes to the 2023-2024 Standard Plans for both road construction and bridge construction. If you have any questions as I go through the slides, feel free to post in the chat. We will try to monitor the questions and respond. Okay, here's a short agenda of what we will cover today. First, I will give a quick and brief overview of the website and changes that were made to the standard plans this cycle. Then I will go over some of the changes that were made to the standard plans in a little more detail. Then Richard Stepp will cover updates related to both lighting and barriers. And Joshua Turley will cover some of the structures and bridge related updates to the standard plans. All right, let's start with a quick reminder about our website. Here you can see the web address. Hopefully all of you are familiar with the address and our website. We really didn't make any major changes to the website this year. This is still our main page for both the road and bridge construction. This is where you can access the current version of the standard plans and the SPIs, previous versions of the standard plans. You can also access DGN files for each of our indexes, the archive design standards, which were replaced with our current standard plans about 6 years ago. You can also access any standard plans that are under review here on this page. And as always, if you have any questions regarding the standard plans and you don't know exactly who to contact, you can always contact myself or our state standard plans engineer, Durwood Shepard. Our contact information is at the bottom of the page. Here you can see where the Track the Status revision link is located. Because this review process is already complete and these changes were already made and posted, the information that would normally be there has been moved to the archive where past year revisions are located. Here is all the links, and here is the 2023-2024 link. You can see that we do have quite a few changes, but not many of these changes were policy changes. You can also see the links to the comments and response forms here. Since these changes were not policy changes, I'm not going to cover every change in the update training today. I picked some of the major changes, as well as a few projects that require coordination with multiple offices. I do want to show you how to find the latest edition of the standard plans. The newest release of the standard plans, the 2022-2023 version, is located at the top of the page once you access the standard plans link here. This page is useful as it has the effective date of the release, so you know you are looking at the correct version of the standard plans, a link to the bulletin that released the standard plans, a link to the interim revisions, and a link to the page that has the DGNs and CAD files. Here we can access the latest release that has all of the indexes for road construction and bridge construction. You can see the indexes listed here with links. This is also one of the places you can access the erratas and developmental standard plans. I always want to point out the revision log. Although I will not cover every single revision today, all revisions, sheet by sheet, small or large, are listed on the revision log, which is located on our website. So that is my quick overview of where you can find the changes and a review of the website. Now I want to get into more detail on some of the updates and additions to the 2023-2024 standard plans indexes. As I mentioned earlier, we had a great deal of revisions, but many were minor or just administrative, so I will only cover and review a few of the more critical updates today. One of our biggest projects was done in conjunction with the State Traffic Operations Office and the State Program Management Office to move materials and manufacturer requirements from Standard Specification Section 700 and Standard Plan Series 700 to the Specification Sections 962, 965, and 995. Separating the manufacturer's requirements from contractor's requirements will help with the review of APL product submittals, field installations, inspections, and acceptance criteria. There was some information moved from the Standard Plan 700 series to Specification Section 700 to prevent duplication and to stay consistent with where direction to the contractor is located. Here you can see a list of each spec and index that was revised with this project. I will not go over each index in detail, but I will pick a few to highlight to give you an idea of the changes. If you want details on what changed on a specific index, please refer to the archive link I covered earlier with the origination form and red lines. You can also check the revision log for more details. Here, the cantilever sign structure, index 700040, is an example of what we changed on the 700 series in the standard plans. We deleted notes that were repetitive. We moved the material notes to either specification 962 or 965, and we moved appropriate information from the index to spec 700. There were cases where we moved the information to other sheets in the indexes, like note 5 here. And as you see with our new note 1, we made sure that each index in the series had a note that read something like this: meet the requirements of specification 700. Here's what the finished product looks like. In some cases, like here, a lot of notes have been removed. So the reason I chose this specific index in the 700 series to highlight is that in addition to moving material information to the spec, we did make a few changes at the request of the Structures Office. We added a new note on the weld pattern for the BD plates shown on sheet 2. We also added a couple of callouts on the nuts and washers that were previously in the notes on sheet 1. We made very similar changes to index 700041 span sign structure on the welding pattern and added some splice notes on sheet 5. So check those out as well if you use these indexes much. This index, Enhanced Highway Signing Assemblies, 700-120, was part of the 700 series project, so it had the material notes moved to the specs, etc., like the other indexes in the 700 series. but it also had additional changes. One change was adding the solar power assembly details. The solar power assembly and battery unit for the wrong way vehicle detection is larger and more powerful than the one that is used for a typical enhanced highway signing assembly. As a result, the solar panel must be ground mounted, and a ground mounted UPS or uninterruptible power supply cabinet must be provided. Both the solar panel and the UPS cabinet must be installed close to the right-of-way line outside the clear zone. We also updated the callout references and notes. Here is the new sheet for the new details, updated notes, and revised callouts. We added a new note 4 that directs users back to index 676010 for cabinet installation details. This is a common approach we use to prevent showing duplicate information in multiple indexes. I did want to point out something on one of our temporary traffic control indexes. Index 102604, a 2-lane, 2-way intersection. On this index, we deleted note 6. This note was added to specification section 102-9 to consolidate guidance to the contractor for temporary signal timing. Here on the low profile barrier index 102-120, we had issues and discrepancies with the type of bolt used regarding the tension links in the districts. This led us to add the new tension link detail here on sheet 2. This was another team effort project. Redeveloped index 350-001 as it was in need of an update. There were several items in this index that were outdated or not used. Mary Jane Hayden and the State Pavement Design Office worked with a task team consisting of FDOT staff, design, materials, and construction, and industry partners, suppliers, CEI, and contractors to address details that were no longer needed, items that should remain, and items that should be added. Several of the new details were found to be best practices that were already in use by other state DOTs. There was some general cleanup simplification on all sheets, elimination of outdated or unused details. Here on sheet 1, you can see there were notes moved or deleted, and the contraction joint detail was deleted. Addition of the new joint layout details for the intersections. Here you can see the redeveloped index, including some details that were removed from sheet 2. Next is the red line for sheet 2. Some of these details were moved to sheet 1, and some of the details were deleted. Here is the new sheet 2. You can see the contraction assembly and expansion assembly details moved from sheet 3. Also added the dowel bars cap, the dowel bar layout, and relation of the tie bars to the dowel bars details. The sheet 3 red line shows deleted and moved information. The new Sheet 3 shows the joint layouts for different intersections. Here is the new Sheet 4 with the isolation joint details. Here is the red line of the old Sheet 4, which is now the new Sheet 5. I changed note and added new 15-foot dimension to the 2 through lane details. And here is the new Sheet 5. The next index I want to go over is index 524001, ditch pavement and sodding. This index was long overdue for redevelopment. Tim Hawley from our drainage group was the official originator on these revisions, even though we have had these updates on our radar for years. We reorganized the index for clarity and to reduce clutter. Moved the joint language to the specifications, which should help clarify the process for construction of joints for slope pavement and ditch pavement. Here on Sheet 1, we reorganized the notes and details. Updated the notes to make them plain language and clarify any hard to comprehend language. Moved General Note 2 and 8 to the standard specifications, and moved Note 5 and the other ditch matting and weep hole details to Sheet 3. Here is the final product for Sheet 1. It's a much cleaner look with the duplicated notes deleted, and we merged other notes into the specifications. Same thing here with Sheet 2. There was no real new data added. We just cleaned up the sheet and reorganized it. And here is the final sheet for the index 524001. This is Sheet 3. No new data was added here. It was just reorganized and cleaned up. Next, let's briefly look at Index 641-010, concrete poles. Joshua Turley is going to cover this index later, but I wanted to mention a global change that was made to the indexes. Class 5 special concrete was removed from the specifications by the State Material Office, so any reference to this was changed to Class 5 concrete in the standard plans. The next set of indexes include indexes 641-020, 649-020, and 676-010. These changes were initiated by our traffic group over at the TERRL, or the Traffic Engineering Research Lab. These revisions were developed based on implementing maintenance service slabs for ITS cabinets. This was recommended during the Turnpike's TDH migration and integration into statewide criteria. The TDH, or the Turnpike Design Handbook, was integrated into other statewide policy and guidance documents this past year. This process resulted in a lot of changes to the standard plans, specifications, and the FDM. Language was also added to specification 641 and 676 regarding the maintenance service lab. We reorganized 676010, the cabinet installation details index, and added the maintenance slab details. The update also changed all maintenance slabs to 6 inches in depth. Real quick, here's the new Sheet 2 for Index 676010. We added the details for both ground and pole mounted Intelligent Transportation Systems ITS cabinets and service slab requirements. Here's another new sheet for Index 676010. This is Sheet 3, and it has 2 new details, the interconnect junction box and a pedestal mounted cabinet. Okay, so next I will go through 641020 concrete CCTV poles. I am not going to cover Index 649020 steel CCTV poles because the edits were very similar to 641020 and 676010. See here that the updates were made to add the maintenance slab details like I discussed with Index 676010. Okay, here is the final product. You can see we also added Note 5 to reference 676010 for more cabinet installation details. And here is Sheet 2 with the maintenance slabs added. Now here on Sheet 5, we had a few more updates. First, we updated the concrete CCTV pole grounding detail to show the maintenance service slab and the ground mounted and pole mounted cabinet details, just like the other sheets. We also updated the concrete slab callout to maintenance service slab. We added the 6-inch apron and changed title to pool box in detail A. And we added title primary ground rod assembly to detail B. Okay, so here is the updated Sheet 5 with all the updates I just went over to the various details. Okay, so that covers everything I wanted to talk about and highlight today. I know this was a very brief and fast-moving overview, so if you need to review any of the changes, please utilize the resources on our webpage. You can still add questions directly to the chat as long as this webinar is active, or you can email me directly if you prefer. We will either respond to all your questions directly in the chat or send out an email with all the questions and responses to the registered attendees. Like I mentioned previously, Richard Stepp and Josh Turley will cover some more standard plan updates now. Richard is up next and will cover some barrier updates and talk about the lighting updates and criteria that he has been working on. Thank you.
Hello, and thank you to Rick and Brian. Again, my name is Richard Stepp, Standard Plans Engineer with FDOT Central Office in Tallahassee. In this standard plan cycle, I was primarily responsible for the following updates. Index 521001 for concrete barrier, Index 521010 for opaque visual barrier, the Index 715 series for lighting, Index D521005 for concrete barrier at toll sites, and last, Index 550804 for pedestrian channelization fencing. And first up, we'll discuss some minor revisions made to the concrete barrier standards. Here we've revised the surface finish type and also added a note to allow for minor grade separations for median barrier. So taking a look at sheet 1 of the concrete barrier standard, we've revised General Note 1, which affects surface finish treatment for all concrete barriers throughout this standard. Essentially, we're calling for a general surface finish treatment per specification 400, which should result in cost savings throughout. Previous years, we called for the Class 3 surface finish, but the Structures Design Office helped us determine that that's no longer needed moving forward. And so now we can keep things a little simpler. Moving on to sheet number 2 for median barrier, we've added a new note number 5 to allow for a minor grade separation. And so what this explains is that for the basic symmetrical types of median barrier, the pavement surface elevation may be placed up to 2 inches lower on one side of the barrier. And so this helps provide the designer a little bit of leeway for grade separations without switching to the more complex and costly median barrier shapes. And so zooming in on the detail, this is how that would look. You can see that the normal embedment for the standard median barrier is 6 inches deep. And so lowering the pavement on one side would still provide enough embedment for a crash-worthy design. And so contractors would be able to construct it this way if it was called out in the plans. So again, this would require a project-specific call-out from the roadway EOR. And then next up on sheet 2 is a fairly simple addition. We've expanded this notes heading from notes to median barrier notes. And so these standard plans are organized so that this sheet is the first sheet in the median barrier section. And so the notes on this sheet apply to all details throughout the median barrier section on sheets 2 through 12. And so basically it helps to clarify that these notes apply to all sheets that have the title beginning with median barrier. So for example, these notes would apply to the median barrier grade separated sheet. And similarly, moving on to sheet 13, this is the lead-off sheet for sheets 13 through 19 for shoulder barrier. And so we've revised this notes heading from notes to shoulder barrier notes to clarify that these notes apply to all sheets that have the title beginning shoulder barrier. So these notes apply to sheets 13 through 19. So for example, the sheet entitled shoulder barrier section options would also follow the requirements of these notes. And now moving on, we'll discuss Index 521010 for opaque visual barrier, where we've added some new barrier delineator details. And so taking a look at the new section details on sheet 1 circled in green, you can see that the barrier delineator locations are now shown as required per specification 705. And so basically when you have a barrier that has no opaque visual barrier on top, the barrier delineators would be mounted simply to the top center of the barrier. But when the opaque visual barrier is there, that obviously is not possible because it occupies the same space. And so for this case, you can see that there will be one barrier delineator on either side of the opaque visual barrier that use a side mount as shown. And per specification 705 and this callout, you can see that the spacing is 100 foot max for these barrier delineators. This follows the same 100 foot spacing requirements for concrete barriers as referenced from 521001. And so to support this barrier delineator instruction, note number 9 was revised. And so sometimes you'd have a median barrier that has split barrier sections that would divide apart and run separately for going around bridge supports or sign supports or things like that. So in that case, per the SPI, the opaque visual barrier only runs on one side, on one of the split barrier sections. And so for this case, per the note, the barrier delineator would only be placed on one side nearest to the traffic. So basically the barrier delineator only goes near an impact face. On the split section on the other side, that doesn't have the opaque visual barrier, the barrier delineator would just be mounted to the top of the barrier because there'd be no space conflict. And so these delineators should only go near the sloped impact faces. You wouldn't want to delineate a portion on the inside of a split barrier section because that may be misleading to drivers as to where that nearest barrier face really is. And so when it comes time to call for opaque visual barrier in your plans, please take the time to review the standard plans instructions and also the notes in the standard plans to understand how these things work. And next up, we'll take a look at the Index 715 series for lighting, where we've added new luminaire tilt details, a new spread footing foundation option, and a new lighting data table. So first, looking at Index 715001, Sheet 1 is our new luminaire tilt detail. And so the luminaire tilt is a fairly common term for those that are familiar with the design process, particularly when using software like AGI32. But it turns out that some folks that are new to design and some contractors had some issues with envisioning how this luminaire tilt was supposed to look. And so contractors and installers that wanted to insist that their installation was okay as is really had no definitions or drawings to take a look at to ensure that they were doing it correctly. So as a result of that district feedback, we've added this detail. So basically, luminaire tilt is the rotation of the luminaire as it's shown here. The axis of rotation, as shown in blue, is defined as level and perpendicular to the tenon. So basically, we're seeing a side view of the luminaire pictured, and then the axis of rotation is coming directly in and out of the page. This axis of rotation may be a hinge, and that's how it's shown here. Some of the luminaires have a hinge, or it may be just a tenon connection. So some of the luminaires have different teeth inside of that tenon connection, and the luminaire's tilt can be adjusted that way. So a 0 degree tilt is considered level. That's shown as the baseline here. Also, the default drawing is shown level up at the top. So 0 degrees projects the light straight downwards towards the roadway. And 0 degrees is the default unless otherwise called for in the plans. If there is a tilt called for, you can see where the tilt angle is shown here in the detail in the enlarged version. And this maximum tilt angle is 15 degrees. And that tilt angle is only allowed under certain context per FDM 231. So please see FDM 231 for usage, and we'll also show where this information is placed into the lighting data table later on in this training. So next up, now we're taking a look at standard aluminum lighting, index 715002, sheet 5. And here we have an all-new spread footing option. This was added at the request of the districts and with the help of our structures design office. And so the first thing here to emphasize is that this is a foundation option. So that means it is optional, it is not default, it is used only where it's shown in the plans as decided by the EOR. The default option would be the drilled shaft that has already been in place in standards for previous years. But for the special cases in urban areas where space is limited, this spread footing option allows for a shallow mount to avoid underground utility conflicts, and it also basically becomes integral with the sidewalk, and so it performs the dual role in that way. And so one thing to mention is this foundation is used with a single arm light pole only, which is oriented towards the roadway. So in this drawing, you can see that the roadway is up here at the top of the page, and then this anchor bolt circle is where the pole would go. So the light fixture in the arm would project towards the roadway and over this concrete spread footing in order to balance properly. And so as mentioned, it's really meant to function alongside a sidewalk as pictured, and it basically performs as a sidewalk. So the notes read that the top of the slab is to match the sidewalk cross slope and the texture. So you can see pictured here there's a sidewalk to the right, separated by a 1/2-inch joint filler, and the note also explains that the sidewalk can be on both sides, obviously for a continuous sidewalk function. The spread footing length required is shown in this top dimension here, and that corresponds to the luminaire mounting height and the design wind speed. So obviously the taller the mounting height and the higher the wind speed, the longer and larger the spread footing foundation has to be. The foundation is designed for use with urban and suburban sidewalks per FDM 222. So per that FDM requirement, the sidewalk needs to be 6 feet wide, and it also has to maintain a 48-inch clearance minimum for pedestrians to pass by. And so this design, with the light pole placement shown here, satisfies both that width and the 48-inch clearance requirement. So now looking at sheet 2, we've made some minor revisions to the schematic details and their titles in order to support this new spread footing option. So basically you can see that we've added the spread footing to the elevation views, along with the small note on how it connects to the curb per index 522001. And then it is important to note that these are just example views, and so per the explanation in the parentheses below, both the spread footing option and the shaft option can be used with a luminaire fixture arm mount or a pole top mount. So these are both interchangeable and compatible with either foundation option. And again, the old shaft option to the left is the default unless the spread footing option is called for in the plans. So that's how the standard plans notes explains it, and the spread footing is only used where it's needed, where those space constraints exist. And now looking at sheet 4, just a little more housekeeping to accommodate that new spread footing option. We've changed some of these titles and headings so that it's known that the shaft foundation is an option. And rather than simply calling this a foundation, we now call it the shaft foundation. So again, just making it clear that it's one of two options. And then a little more housekeeping just to keep our definitions consistent. In all of these tables for the luminaire elevation, we've now changed this to say mounting height. And so this now matches the FDM 231 design terminology. This is basically referring to the distance from the finish grade at the base of the pole to the bottom of the luminaire. And then flipping back really quickly to the previous slide showing the elevations, you can see that the mounting height is shown here, measured from the finish grade to the bottom of that luminaire or light source. And so this mounting height term should be consistent everywhere you look. And this includes the input for our new lighting data table layout. And so here we can introduce our new lighting data table. This was developed in coordination with our district lighting experts. And then we also worked with our CAD systems office in order to make this happen. And so this new table was released with the FDOT Open Roads design package on November 18th. This goes with the new MicroStation ORD CAD features. This new table also corresponds to the next-gen production requirements of FDM 943 for lighting plans. The idea is to consolidate as much of the lighting information as possible for contractors and future asset maintenance on one sheet. And so this consolidates information that was previously listed in the lighting legend. So now the idea is that the lighting legend will just have pretty simplified symbology. And when the contractor wants the real detailed information per location, they'll look to the corresponding pole number in this lighting data table. And so listing this information out per pole is practical even if the information gets repetitive, because the input tools do allow for the data to be copied down, and you could also manipulate the data in an Excel spreadsheet. And in addition to consolidating the information into one table, we've also added new information as requested by the districts. And then one more feature that adds some convenience in the design phase is that each of these column headings offers drop-down selections for inputs that match the standard plans options. And so the first column headings we'll take a look at are new easting and northing inputs as requested by the districts. So it was pointed out that the typical baseline, station, and offset are getting to be a little bit old school, and that method of locating lights and poles may not be available in the future, particularly for those maintaining the lights in the future. So here we've added the basic easting and northing, and that assists with future asset maintenance locations. And I do want to point out that some district offices prefer to have the easting and northing in addition to the baseline, station, and offset, while others just may prefer one. And so this table and all the column headings we're about to show are modifiable. Some may be removed at the discretion of the EOR, but it really is about what works for each particular district. And so next up, we have a new table entry for the foundation. And as part of this with the CAD tools, the new drop-down selection has all standard plans options, including the shaft option as shown in 715.002 that we discussed earlier. It's also in 003 for the utility conflict pole, as well as 010 for the high mast lighting. So here you can see it in 715.002 and then 715.010 for the high mast. The drop-down option has spread footing just by itself, which is the new option we discussed for 715.002. You can see it pictured over here. Additionally, in 715.002 is a pole mount on top of a barrier, on top of a spread footing. And so you can see that pictured all the way at right. There's then a pole on top of a barrier, on top of a cylindrical foundation. And cylindrical is the way it's labeled in 715.002, which you can see right here pictured. There's then a mount on top of a barrier, which is then mounted on top of a bridge deck, which you can see here in the lower left. Next is the pedestal mount option for 521, 650, and 660. One of those is pictured here at the bottom right. There's an option for not applicable if the light happens to be mounted to an underdeck. And then there's also an option for project specific if there's a non-standard option shown in the plan's details. And next we have three inputs that define all the dimensions for a light pole. And so these correspond to our standard plans labels. Those are arm length, arm rise, and mounting height, as shown up here in the table. And at right, as our example, we have our utility conflict pole, shown in the elevation view, but these dimensions also work with our standard aluminum lighting details in index 715.002. And so to repeat, we'll show you how these dimensions correspond to the standard plans drawings. The drop-down selection has all the standard plans options, including the arm length, as shown up at the top. For example, 16 feet would be the extreme case for the utility conflict pole, and 0 feet is the opposite extreme that would be used for no arm and a pole top mount. NA means not applicable, and that may be used for something like bridge underdeck lighting or sign lighting. Arm rise is the next dimension, shown here over to the right, and again 15 foot is the extreme, used for the utility conflict pole. 5'6" is the greatest for standard aluminum lighting, and 0 would be a pole top mount. And last, the mounting height, as we discussed earlier, is measured from the finish grade at the base of the pole up to the bottom of the light source, or the luminaire, and the selection are the options shown in the standard plans. And per the SPIs, the lower heights are for the wildlife sensitive lighting, and a 50-foot mounting height is the maximum for all cases of conventional lighting, including the utility conflict poles. And then not shown in this elevation view example would be the high mast lighting standard plans options of 80, 100, and 120 feet. And so moving on, we have a new input for the quantity of luminaires per location. And so this is just based on the standard plans options that we'll show below. So first is the single arm light pole, and so that would have one luminaire. So you just put one in the data field. The same with pole top luminaire. Simply put one in the data field. We have a double arm luminaire, and so you list two, since you have two luminaires per pole. And then the last example is the high mast light pole, where you'd input between 4 to 8 luminaires for the standard plans options in the EOR's design. Next up is the input for correlated color temperature, also known as CCT, per location. And so these standard input options on the drop-down menu follow FDM table 231.2.3. So the first option is the 3000 K color temperature, and this will be used in the vast number of roadway designs, including limited access facilities. And then next is the 4000K option, which offers that very white light that almost resembles the fluorescent lighting. The colors pictured here actually are a little bit warmer than the results that you get in the real world. So the actual results are actually a little bit whiter than what's shown here. But this 4000K is only used in a few very specific cases in urban and suburban contexts with the very high design speeds. And last, going even a little bit warmer than our standard 3000K option, 2700K is available for design speeds of 35 miles per hour and less. And this helps for aesthetic locations like residential areas, parks, coastal areas, tourist areas, and downtown areas where there's some concern for the nighttime ambiance. And for more information on the background and design nuances of this topic, please see the RDO training website as shown in the bottom left and look under the March 2022 heading. Moving on, we have a new heading for our luminaire tilt angle input. So this corresponds to the angle shown here, as in the new index 715001 detail we discussed earlier. And so per FDM 231.2, the input options for luminaire tilt are 0, 5, or 15 degrees. So again, please refer to this FDM 231 for the usage conditions of these different tilt angles. And now to round out discussing this lighting data table, we'll just go ahead and list out the remaining input variables that are now included. And so first is the type of lighting per FDM 231. So that could be conventional, high mast, underdeck, wildlife, or sign. We then have inputs to define the design luminaire, including the make and model of the design luminaire, the EOR selected for the project for the photometric analysis, the lumen output of that luminaire, the IES distribution type, where the options are 1 through 5, the luminaire wattage, the volts, the load center number that this is connected to, the circuit number that this is connected to, and the maintaining agency. And as mentioned before, some of these headings are here for the convenience of the designer and helping to communicate this information to the contractor. So if mentioning only the circuit number is sufficient, then something like the load center number can be removed. And then as always, the pay item number is included at the end. And I just want to point out that the pay item is for the pole and luminaire system. So that wouldn't include the load center that this is connected to, even though load center number is listed. The pay item is generally for something like light pole complete. And so with that, we'll close out our lighting topic and move on to discussing some of our developmental standard plans. And so in general, developmental standard plans are used for some of our newer ideas and innovations, or just basically contract details that could benefit from the guidance and approval of central office in the design phase. And so to use a developmental standard plan, you basically follow the procedure of FDM 115, and you contact the central office monitor for the review and approval of the usage. And again, this happens in the design phase. So that said, we'll take a look at one of our newer developmental standards. That's index D521-005 for concrete barrier at toll sites. And this has been out there now for a little over a year. We've been continually adding some options to it. And this is mainly for Florida Turnpike enterprise designers. So the idea here is to just keep this brief and just give this a quick shout out so that Turnpike designers know of the availability of this standard. And so as mentioned, this is for Florida Turnpike enterprise usage. As a result of our quality assurance reviews, or QARs for the Turnpike, we had discovered that barrier details and reinforcing details for these complex scenarios of toll site barriers might have been lacking, and so Central Office wanted to help and provide some guidance for this. These toll sites are actually very interesting and complex. They use some high technology for detecting vehicles that steel structures may interfere with. So for that reason, we provided barrier designs that use glass fiber reinforcing, or GFRP, throughout these barrier layouts. And with that, we'll just quickly walk you through and show you some of the features so that you know what's available within this developmental standard plan. And so these details were developed in coordination with the Florida Turnpike Enterprise engineers. This works with the FTE General Tolling Requirements, also known as the GTR. The standard basically has 10 toll site barrier schemes. Here, just for example, we're showing scheme 9, but there are others, and essentially the EOR would call out what they need and follow these layout dimensions in their roadway plans. The standard provides locations for the pull boxes, the overhead gantries, both span or cantilever, the toll loop pavement area, which corresponds to the GTR, and the toll head or curb as needed for flexible pavement. And then really the main reason for developing this standard was to ensure that the correct reinforcing was used throughout all these barrier shapes. And so sheet 12 provides all of the reinforcing details or features shown throughout all of the schemes and layouts. And so details are provided for the GFRP reinforcing, the flowable fill locations, as you can see between the split sections, the gantry support anchors, which is basically the schematic location for the project specific design, and the reinforcing connection to the concrete median barrier as shown per index 521001. That's shown on the left side of this detail. The standard also shows all the barrier sections corresponding to the scheme layouts and reinforcing details on the previous sheets. The GFRP bar bending details are then shown on sheet 14. And so for more information on how to incorporate this barrier standard into your toll site design, please work with the General Tolling Requirements and the Florida Turnpike Enterprise Office. You can also contact me as the monitor for this standard, and I'll put you in touch with the right people. And moving on, last but not least, we have another developmental standard plans topic, Index D550804, for pedestrian channelization. And so here we've now introduced a new proprietary fence option, which can be considered a game changer in some respects. And because we have something new, I saw this as a good opportunity to quickly review the basics of the usage of this fence. And so pictured here is the old steel loop fence. This is one of the rare developmental standards that's been around for a good number of years because we've really been able to help guide successful usage of this standard from central office. And so the basics are pedestrian channelization fencing is used to guide pedestrians to marked crosswalk locations. This helps to make pedestrian crossings more visible and predictable to drivers. So you can see pictured here we have somewhat of an ideal case where a channelizing fence ends within a few feet of a marked crosswalk on both ends. This could either be an intersection crosswalk or a mid-block crosswalk. And so I do always like to point out that fencing is not really a new idea. A fence is not a new invention, and so there's a reason it's rarely been used on medians and roadways in prior decades. Basically, a fence is considered a sight obstruction for vehicles. A fence creates an additional obstruction on the side of roadways for errant vehicles to possibly run into. Fencing increases walking distance and can make pedestrian travel less efficient. The installation of pedestrian fencing can be expensive. And last, the maintenance cost for fencing can be expensive if it's frequently hit by vehicles, particularly for this high-cost custom fence that's made out of solid steel and designed to prohibit climbing. And so the bottom line is the fences do carry a high cost with them, and they're really only approved for use in ideal locations where they're going to definitely provide a benefit and where a real serious pedestrian concern has been established and proven. And so that said, pedestrian channelization fencing is only used where district office determines critical safety need exists. And again, this is a pretty rare case. The fence is only used where it ends within a few feet of a marked crosswalk, typically on both ends. And so this is another thing that's important. If the fence ends mid-block or it doesn't end near a marked crosswalk, pedestrians have a very strong tendency to just walk in straight lines and likely just cross at the end of the fence, even if there's no marked crosswalk nearby. And so that really doesn't provide much of a safety benefit. And then all of the other costs mentioned, including the additional sight obstruction, outweigh the benefit of the fence, and the fence just wouldn't be approved. Next, the fence can't violate requirements for design speed, sight distance, and the offset from the road, as shown in the standard plans instructions. And so currently I want to point out that our legacy fence is still available. That's the Type P1. This is a really heavy-duty solid steel fence that was derived from the fence used on Tennessee Street in Tallahassee near the FSU campus, which in turn followed the design used in Nevada on the Vegas Strip. And so this is a heavy steel design with a high cost. It's considered to have a premium aesthetic. It has no horizontal members, which adds to the crash worthiness, so you don't have horizontal members that can cause spearing hazards for vehicle windshields. And last, it's designed without horizontal members for climbing resistance, so it's difficult for pedestrians to climb over. And now that we've discussed the standard plan's legacy design, I'll introduce the new Type 4 proprietary alternative steel fence. And so we've worked this past year to get this new fence on the innovative product list, otherwise known as the IPL. This is found under DEV 550. And so because it's proprietary design, not custom made and welded together like the steel loop fence, it does have a significantly lower cost per foot, so that's certainly beneficial. It has an aesthetic clear mesh. The brand name is Clearview, so the idea is that you can see through it, although we still do consider this to be a sight obstruction. The tight mesh just has a much higher quality aesthetic look. It certainly looks less urban than a chain link fence. It does have these really nice coating options available as requested by FDOT, so the fence can be either a black color or a hunter green color as shown over here at the top left. So that does help it to somewhat blend with the environment and look more natural, especially when paired with landscaping. This fence also has no rigid horizontal members, so you don't have horizontal members that can cause spearing hazards for windshields of errant vehicles. This fence also has climbing resistance. It accomplishes this by having a tight mesh so that feet or hands have a hard time getting into the mesh grooves, and so it's more difficult to get a grip or a foothold. The fence is 4 foot 6 inches in height, very similar to the steel loop fence. The fence also has delineators at every post for better nighttime visibility. As you can see here in the drawings, it says reflective adhesive on each post. And to additionally assist with delineation and to also add some aesthetic, this particular manufacturer offers durable decal designs that can be placed out between the posts as shown. And so that should help to see the location of the fence mesh more clearly. And it also just adds a nice aesthetic feature to the area. So in this case, we show a flamingo and some palm trees, and obviously that goes along with the Florida style. These decals get melted into the fence coating at the fabrication stage, and so they should hold up through the years. And so the developmental specification that supports Index D550804 has been updated to account for the Type P4 fence. This fence works with the developmental standard plans by way of being called out in General Notes 2 and 3 on Sheet 1. And so you can see Note 3 at the bottom of this slide. The standard plans instructions has also been updated to give some guidance on this proprietary fence. And last, the pay item for Type P4 has been added to the BOE and it's now available. And so when considering the use of pedestrian channelization, please consider the Type P4 proprietary fence. It's actually a pretty state-of-the-art design that's used elsewhere by the industry for security of government buildings and important landmarks, and so it's very durable and difficult to cut. And as mentioned, it's difficult to climb while also being of lower cost than our legacy fence design. And with that, we've reached the end of my particular update training segment. Once again, I'm Richard Stepp, and if you should have any questions on these lighting or barrier standard plans topics in the coming weeks and months, please don't hesitate to reach out to me directly at the contact information given here. And then also, we know that you've been providing questions in the chat box, so I'll go ahead and take a look at those and attempt to respond to as many as possible as I can during this training session. And for any we don't get to, I think that we can send you a follow-up email. So having said all that, this concludes my part, and thank you for your time and attention.
Thank you for attending the 2023-24 Standard Plans Update Training. My name is Joshua Turley. I'm the Standard Plans Engineer for the Structures Design Office. I'm going to take you through some of the notable updates to the structure standards in the 23-24 book. We didn't have a lot of major changes this year, so this will go fairly quickly. On Standard 415.10 for the FRP bar bending details, we added a stirrup shape. Previously, these were formed with 2 U-bars. For the 455 series, this change is a materials change, where as a department we have eliminated the Class 5 special concrete mix, and now we have only the Class 5. This material was removed from all the similar standards in the 455 series. On the next several standards, we have detailed the concrete buildup to be a Class NS concrete, which, though it is a non-structural mix, it has sufficient strength for its purpose, and of course is more economical. Here we've changed the CIP buildup on 521-611 and also on 521-620. On 521-630, we have again changed the buildup to the non-structural concrete, but we've also fixed the top of footing dimension and added some clarifying language changes to the annotations. On 641-10, the concrete pole standard, we added a 16-foot service pole version. We previously had a 12-foot and a 36-foot version. On 455-440, the FRP precast concrete sheet pile wall standard, we changed the width of the stirrup for the thinner cross section. Before, we would have to tilt the stirrups to fit them in the shape, but due to the updated FRP bending radiuses, we can bend a tighter corner on the strip and fit these into the shape without tilting the bar. For the voided piles for standards 455, 30, and 31, we revised to an earlier version of the standard where we provide a vent hole to vent the voids. And that's all we have for today. Many of the other changes were small corrections and clarifications. If you have any questions, I'm always available at the FDOT email address here. If I don't have the answer, I will get the answer. We always appreciate your feedback and suggestions for improvements to the standards. Thank you for your time today.